In this video, we're going to look at the rational equation 1 divided by x minus 3 minus 2 divided by x plus 1 equals 8 divided by x squared minus 2x minus 3. And first of all, we want to write our restricted values, then we want to actually solve the equation. So anytime we're talking about a rational equation, specifically one like this where we have variables in the denominator, we need to figure out what those restricted values are first. In this case, any value of x that would cause us to have a 0 in the denominator. Now before we even get to that, let's do an intermediate step, and let's look at the denominator for our third term, or the one on the right hand side of the equal sign. We have x squared minus 2x minus 3. And so what we want to do in a problem like this from this section is we want to look at that and see if we can't factor it, because 9 times out of 10 that's going to factor into potentially the other two denominators multiplied together. So let's go ahead and just play around with this x squared minus 2x minus 3. And you can just factor that. It's a trinomial, so let's get our two sets of parentheses, x and x. The factors of 3 are 1 and 3. And that's going to be a positive 1 and a negative 3. And so x squared minus 2x minus 3 is the same thing as x plus 1 multiplied by x minus 3. And notice those are the two denominators that we have prior to that in the problem. So let's go ahead and let's rewrite the third term. Let's take away the x squared minus 2x minus 3, and let's rewrite that as x plus 1 multiplied by x minus 3, because those are the same thing. So now let's talk about the restricted values. So looking at the different components we have in the denominators, the only unique components we have are the x minus 3 and the x plus 1. So let's set each of those, x minus 3, to where it does not equal 0, and x plus 1 to where it does not equal 0. Then of course if we add 3 in the first one, we get x does not equal positive 3. And in the second one we get x does not equal negative 1 if we subtract 1 from both sides. And so our restricted values for this problem are positive 3 and negative 1. So in other words, if we solve this rational equation and get down to the end and we get x equals one of these two numbers, then we know we have to throw out that solution, and we say there is no solution. So now that we have the restricted values in place, now that we've rewritten the problem to make it a little bit easier to work with, let's actually solve it. So what we want to do, of course, since we have denominators, is we want to get rid of those denominators. And the way we're going to do that is we're going to multiply by the least common multiple of our denominators. So our denominators are x minus 3, x plus 1, and then x plus 1 multiplied by x minus 3. So our least common multiple of our denominators is going to be the x plus 1 multiplied by x minus 3, or the multiplication of all of the unique parts. So let's multiply that by each of the terms, x plus 1, x minus 3. Multiply the 2 by x plus 1, x minus 3. And multiply the 8 by x plus 1 multiplied by x minus 3. Now looking at our first term, we have an x plus 3 on top and bottom, so that's going to cancel. That's going to leave us with 1 multiplied by x plus 1. But of course 1 multiplied by anything is just itself, so we can write that as x plus 1. In our second term, we have an x plus 1 on top and bottom. So those are going to cancel each other out, and that's going to leave us with negative 2 multiplied by the x minus 3. So you want to be sure that you leave that in parentheses, otherwise you'll forget to distribute the negative 2. Now the right hand side of the equal sign in this case is really nice because the x plus 1 and the x minus 3 cancel out on top and bottom, leaving us with just 8. And so again, after our first step, all of the denominators have canceled out, and all we have to do is solve this reduced in difficulty problem. So the first step in solving this is we want to distribute the negative 2. So bring down our x plus 1. Negative 2 multiplied by x is going to be negative 2x. Negative 2 multiplied by negative 3 is going to give us positive 6. And that's going to equal 8. So now let's combine our like terms. On the left hand side we have an x and negative 2x. We have a 1 and we have a 6. And so let's go ahead and combine those like terms. The x and the negative 2x will give us negative x, and the 1 and the 6, 1 plus 6 gives us 7. And then the 8 comes right on down. So now let's get the variable completely isolated, so subtract 7 from both sides. We have negative x equals positive 1, and then we can multiply both sides by negative 1. Negative 1 times negative x gives us positive x. 1 times negative 1 gives us negative 1. So our potential solution is x equals negative 1. And the reason I say potential solution is because we now have to go back and compare that to our restricted values. So in this case, our restricted values were 3 and negative 1. In other words, x cannot equal 3 or negative 1. Well, the only possible solution we got when we worked out the algebra in this problem was x equals negative 1. So since that matches with one of the restricted values, that means that negative 1 is not a possible solution. So in this case, there is no solution. So you can either write out no solution, or you can write the symbol for no solution, which is like a 0 with a line slashed through it. And that's the answer to this one. Unfortunately, there is no answer.